Today we're going to look specifically at areas of regular polygons. If I can just be really blunt with you for a second, this is the section that every year I have a part of the class that just doesn't learn this, and then their grades are quite a bit lower than they should be. Okay? This is the only really, in terms of new formula, that you have to know for this unit. Everything else you've done before at some other place, at some other time. They aren't new formulas to you. This is new stuff. Okay, it's the only section where it's new, and I think that's why sometimes people don't do as well on it. If I were you, I would really concentrate on this part, because everything else you should be fairly good at. It's just adding things together that you've done before. So we're going to start with quite a bit of vocabulary here. So the center of the regular polygon, and I guess maybe we should talk about what a regular polygon is. A regular polygon is a polygon that is both equiangular, meaning all the angles are the same, and equilateral, meaning all the sides are the same. When you were a little kid and you first learned about shapes, if you learned about what a pentagon was, undoubtedly they showed you a picture of a regular pentagon. They didn't show you something that was, irregular. They didn't show you something that looked like this, right? And you're like, that's not a very good pentagon. I'm like, it's a perfectly good pentagon. It's just not regular. Okay? So we're only going to be dealing with areas of regular polygons. So the center is the point that is equidistant, meaning the same distance from the vertices. So it's right there in the middle. That point is the same distance from every vertex. The apothem, some people say apothem, I'll take it either way, it doesn't matter to me how you pronounce it, is the segment from the center perpendicular to a side, and a central angle is an angle with its vertex at the center whose sides pass through consecutive vertices. So in this particular pentagon, this is a regular pentagon, A, B, C, D, E. The center is X. That's pretty obvious, I think. The apothem, we're just drawing in a height here, just like we've done a couple of times now in problems where we draw in the altitude or the height. And then the central angles would be, for example, like angle AXB. This is a central angle. It's pretty easy because its vertex is at the center. So that's the central angle. And this is the apothem. The measure of a central angle, in this case, is 360 divided by 5, because if you look, there are 5 central angles. Now, the apothem splits this one, but there are 5 central angles. So it's 72 degrees. You're going to be doing a lot of these, and after a while, you'll probably memorize some of the central angles, and you won't have to find it every time. But that's the very first thing you do when you're working one of these problems, is figure out how big is the central angle, because that's going to determine what you do next. Something else that this doesn't tell you that you should add to your notes is the apothem bisects a central angle. That means that when you draw the apothem, it's going to exactly split the central angle in half. Now, how do you find the area for this whole thing? Well, we're going to need to define some terms here. N is going to be the number of sides, just like we used when we did n minus 2 times 180 to find the sum of the angles of the polygon. That hasn't changed. For the apothem, we're going to use A. That makes sense. The sides, we're going to use S for the length of a side. So you could find the area of this whole thing by finding the area of just this triangle, triangle AXE, and then multiplying that by 5 because there's 5 of those triangles. Mathematicians, though, like to have the shortest way to do things. So here's what they did. They said it would be the area of one triangle times the number of triangles. The number of triangles, notice there are 5 triangles in this picture, all with central angles. That's also the number of sides. They replace that within. The area of a triangle is equal to half base times height. The base of this triangle is a side of the triangle. So they're going to replace base with side, and the height is the apothem, and they're going to replace that with A. So it's half of S times A times N. If you want to memorize the formula this way, you're absolutely welcome to. I had a student years ago who did, partly because, well, San was his first name. It was spelled S-A-N, and so it was really easy for him to remember. But since the length of a side times the number of sides gives the perimeter, we usually write this 1/2 apothem times perimeter, or 1/2 A times P. That's a formula that you haven't ever used before. You got to memorize this one. If you don't know this formula and you don't know what the things stand for, it's a problem. So here, the A stands for the apothem. And the P stands for the perimeter. All right, so let's do some examples. First one says, find the area of a regular hexagon with sides of length 12 centimeters. If it has 6 sides or fewer, I usually draw the whole polygon. I think we'll get to one in a minute where it has more than that. Actually, the next one has more than that. I don't usually bother to draw them. It just gets too hard. But 6 sides is not a crazy number of sides. So I'll draw the whole thing. Don't draw it really tiny. Make it pretty big. If you're going to err on one side or the other, I would err on the side of making it too big, because we're going to put a lot of things in here. So all these sides have a length of 12. Next thing I'm going to do is I'm going to draw in a central angle. So it's sort of like the hands on a clock. And it's important that I know how big that central angle is. So the central angle is going to be 360 divided by, there are 6 central angles if I drew them all in, gives me this central angle is 60. I'm not going to write that on my figure yet because I'm about to split it in half with the apothem. Drop in the apothem. That's going to split the central angle in half. So each of these is 30 degrees. It's also going to split this side in half. So each of these is going to be 6. In a 30, 60, 90 triangle, what do I have to do to the short leg to get the long leg? If the short leg is S, what is the long leg? Not by 2. That's the hypotenuse is S. Yeah, by the square root of 3. There you go. So this is going to be 6 square roots of 3. So now I just need to figure out what the perimeter is. The perimeter, there are 6 sides at 12 each, is 72. So the area is 1/2 of the apothem times the perimeter. So that's half of 6 square roots of 3 times 72. If you're doing that on a calculator, you just don't put in the square root of 3. You just put half times 6 times 72. And that gives you 216 square root of 3. And since the units were centimeters, this will be square centimeters. So sometimes they're going to give you the length of a side. Sometimes they're going to give you the length of the apothem instead, like in our next one. And this is, like I said a moment ago, when it gets to be 8 sides and bigger, I usually don't draw the whole thing, just because mine look really horrible when I get to more than 6 sides. I am going to draw, though, a great big central angle, and to remind myself that there are more sides than that, I'm going to draw a couple of sides off like that. It always ends up looking like a bent witch's hat or something. Again, after the drawing, the first thing I do is find the measure of the central angle. It's 360 divided by 8, which ends up being 45. Then draw in the apothem, which splits the central angle in half. So this angle right here is 22.5. And the length of the apothem is 7. Now, in order to find the area, I need to know the apothem, which I already know, and I also need to know the perimeter, which I don't know yet. Just like on the last one, the apothem splits this side in half, so this is S over 2. And so is this. So to figure that out, since this isn't 30-60-90 or 45-45-90 triangle, I'm going to use trig. So grab your calculators. Peter, you okay? So from the 22.5, which side is 7? Is it opposite, adjacent, or hypotenuse? It's adjacent. And S over 2 is opposite. So which one has both adjacent and opposite in it in trig? Tangent. So tangent of 22.5 is going to be equal to S divided by 2 over 7. Flip that over 1 and cross multiply. And I get S over 2 is 7 times the tangent of 22.5. This is a little bit different than anything we've done before now. We've never had a fraction over here, but how do I get rid of the 2? Multiply by 2. So S is 14 times the tangent of 22.5. And the perimeter, what would I have to do to this number to find the perimeter? It's an octagon, so how many sides does it have? 8. So what I need to do, if this is one side, how do I find the total perimeter? Yeah, multiply this by 8. So it'll be 8 times 14 times the tangent of 22.5. I don't bother putting that into the calculator because I don't want to round it off yet. So now I'm ready to find the area. The area is 1/2 of the apothem times the perimeter. So it's going to be half of the apothem, which is 7, times the perimeter, which is 8, times 14, times the tangent of 22.5. And your calculator will do all that for you. Just put it in like it looks. 0.5 times 7 times 8 times 14 times the tangent of 22.5. Make sure my mode is right. Yep. It didn't say what to round it to, so I'm going to just round it to 1 decimal place. That'd be 162.4 square inches. Again, if I can be just blunt with you, that's as ugly as these problems get, is one like that, where they give you the apothem and the angle is nasty and the whole deal. Let's do a couple more of these. Here they want us to find the area of this square. They've already drawn parts of it for you. I'm going to finish off the central angle. The central angle is going to be 360 divided by, there are 4 central angles, is 90. Then I'm going to draw in the apothem, which is going to split that in half. So this is a 45, 45, 90 triangle. So remember, in a 45, 45, 90, this is, I'll call it x. I don't want to use s because s is the side length. This is x squared of 2. So x square roots of 2 is equal to 6. Divide both sides by the square root of 2. And rationalize. So it's 6 square roots of 2 over 2. Is 3 square roots of 2. So both of those are 3 square roots of 2. So this is also 3 square roots of 2 because the apothem always splits the side in half. So it's 6 square roots of 2 all the way across. So the perimeter will be 6 square roots of 2 times, there are 4 sides. That's 24 square roots of 2. So the area is 1/2 the length of the apothem times the perimeter. So it's half times 3 square roots of 2 times 6 square roots of 2. Again, on your calculator, we're going to multiply half times 3 times 6. Maybe you can do that in your head. Half of 6 is 3, times 3 is 9. And what's the square root of 2 times the square root of 2? 2. Thank you. So this is 18 square feet.
I thought the perimeter was like 24 square feet.
Oh, did I write in the wrong thing? Thank you. I looked at the side instead of the perimeter. So that's going to make this 36 times 2. So that'll be 72 square feet. Thanks for catching that. By the way, this is a square. You don't have to use 1/2 apothem times perimeter if you don't want to. You could have done area is equal to base times height, because it is. And that'll be 6 square roots of 2 also. So it'd be 6 square roots of 2 times 6 square roots of 2. 6 times 6 is 36. The square root of 2 times the square root of 2 is 2. And it's 72 square feet that way. It's more than one right way to find the area. All right, one more. Find the area if the apothem is 12. So estimate where the center is. Draw in the central angle. That's always your first step, is to draw in the central angle and find its measure. So the central angle is 360 divided by 3 is 120. Draw in the apothem, and that splits the central angle in half. So each of these is 60. And the length of the apothem is 12. In this case, I've got a 30, 60, 90 triangle. And we've got the short leg. So just like in the other one, to get from the short leg to the long leg, the short leg is x, the long leg is x squared of 3, so this is going to be 12 square roots of 3, and so is this. So the whole side is 24 square roots of 3. So I'll go ahead and find the perimeter. It'll be 24 square roots of 3 times 3. 24 times 3 is 72. And now I'm ready to find the area. The area is 1/2 apothem times perimeter. So it'd be half times 12 times 72 square roots of 3. The numbers are a little on the big side, so we'll do 0.5. Wake up. There we go. 0.5 times 12 times 72 should be 432. Yeah. 432 square roots of 3 square millimeters. Any questions about that?